lesson 6.2, Introduction to Sequences. Let me go ahead and get the lesson copy up and get the pen activated. And hopefully you're with me. And there we go. All right. We started chapter 6 a little while ago by actually finishing up methods for solving systems. So this is normally the introduction to this chapter. So this is all about sequences, and this is Algebra 1, so we are going to focus primarily on 2 sequences. Let me go ahead and let's get to the vocabulary. Oh, and like I said, everybody always says I don't introduce myself, so I am Miss Fleming. This is only polite. Of course, I have to be able to write. So for those of you who haven't seen how terribly I write, there we go. All right, vocabulary for this lesson. We have a sequence in general. It is a set of ordered numbers. The order is generated by a pattern. Each number in the sequence is called a term. Now, it's algebra. We're going to focus on arithmetic sequences and geometric sequences, but there are hundreds and hundreds of other types of sequences. So don't think this is all there is, because it's not. All right, arithmetic sequences, they are linear. They're going to function exactly the way a linear function worked. They are going to increase or decrease by a constant rate. So just like you saw the slope was the amount we increased and decreased by, we're going to have something here that is called a common difference. That's the amount we increase or decrease by, and it works exactly the same way. All right, the change from one term to the next, instead of calling it a slope, we call it a common difference, and we're going to do a lot of things where you're going to look for D's. Okay, to find the common difference, you subtract the term preceding it from the term before it. And that sounds really complicated, and it's not. We're going to do it in just a minute. All right, a geometric sequence, on the other hand, is exponential. And we haven't done exponential sequences. We do that in Chapter 7. It's got a star here because it says there's some exceptions. The sequences will vary a little bit from the functions, but not to worry about that yet. All right, what they've increased or decreased by, instead of being a common difference where we add or subtract the same amount, they are going to increase or decrease by a multiplier. So these are going to increase by multiplication or division. The change from one term to a next is called a common ratio. And ratios are fractions, so you're going to see why it's a ratio in a minute. To find the common ratio, you divide each term by the term preceding it. Again, I'm going to explain all of that, so let's not worry about it yet. Okay, we've got a great diagram up here. And it's going to show exactly how this works. And I want you to be able to see the whole thing. So let's see if it will let me bring this down a little bit. It might not. Not really. All right, that's enough of it. And let's erase where it says Miss Fleming, because we're not going to carry that around for the rest of our lives. All right, arithmetic sequence. This is the idea of subtracting backwards. Okay, I find a term. This is the one that precedes it, and I take this term at the end and subtract the term in front of it, and that's how I get a common difference. Now, in order to know that it's actually an arithmetic sequence versus a geometric sequence, I need to do that at least twice. It doesn't matter if I start here, it doesn't matter if I start here, or somewhere in the middle. So, same thing. This term minus the term that's in front of it is going to give me a negative 1.1. And if I keep going, let's try one right here. If I do 2 minus 3.5, I'm still getting that negative 1.5. So I know a couple of things here. I now know that this is an arithmetic sequence. It's not some other kind of sequence. And I know that The common difference, the amount it is decreasing by, is negative 1.5. The first term in the sequence is 6.5. That's the one it starts with. And now it says, okay, what's the sixth term? Okay, well, this is term 1, term 2, 3, 4, and 5. So the sixth term is going to come right here after this term. If I subtracted going forward, this is the fifth term. Let's not get too confusing. Okay, so I'm looking for the term that goes right here. All right, if I subtracted going backwards, then what I'm going to do going forwards is add. So I've got 0.5 plus negative 1.5 and that tells me that the sixth term in this sequence, 0.5 plus negative 1.5, is going to be a negative 1. So if I line this out, this would be a negative 1. All right, now one of the other teachers, instead of talking about subtracting forwards or subtracting backwards and adding forwards, which is what we just did, talks about it in terms of left and right. So let's get a red color and see if that makes any difference. Frankly, as long as you get it, I don't care if you want to go left or right or backwards or forwards. Okay, did it turn red? It did. All right, so this would be left. So the other teacher says what you do is subtract left, and this would be right, and you add right. Okay, let's take a look now to geometric. Don't worry, we've got plenty of practice. Okay, let's switch back to the blue one. All right, up here we subtracted forwards. The geometric one, we're going to divide backwards. Same idea. I'm going to take a term. I'm going to take the term that's in front of it, and backwards means this term divided by that term. So 20 divided by 10 gives me a 2. 10 divided by 5 gives me a 2. The minute I get the same number twice, that confirms that this is a geometric sequence. I know that's a geometric sequence. So I have a common ratio that's a term, or that's a 2, excuse me. And my first term is 5/4 right there. And now it says, okay, what's my sixth term? So this is term 1, this is 2, this is 3, 4, and 5. So we're looking to see the sixth term right here at the end. All right, I divided backwards, so what am I going to do going forwards? I'm going to multiply. All right, so my common multiplier, my ratio right here is 2. So what I'm going to have going forward up here is 20 times 2, and this term is going to be 40. Okay, again, if you want to do it in left and right instead of forward and backwards, let's change that to a blue. And this is left. So it would be divide left. And this is right. And right would be multiply. All right, so we're going to get plenty of examples, but if you keep coming back to this diagram, it ought to help you keep this straight. And let's erase all this. And go ahead and scroll. All right, we have a box here that says we've got a time saver. What you're going to be doing for the rest of this lesson is being given a sequence, so a list of numbers that have a pattern, and you're going to be asked to say, okay, is it arithmetic or arithmetic? If you want to say an arithmetic sequence, that's fine. Is it arithmetic or is it geometric? And sometimes it's going to be neither one. So we're going to learn how to tell the difference and find the common difference of ratio and then find missing terms. But this says, here's a way to save time. Arithmetic sequences, because we are increasing or decreasing by a constant rate, we're going to add or subtract by a constant rate, they're going to increase or decrease slowly. A geometric sequence, on the other hand, may have alternating signs. It may go positive, negative. But if you look at the absolute value of each number, they're going to increase or decrease really fast. They're going to get really big or really small really quickly. And if you can look at it and go, well, I'm going to try arithmetic first because this one is increasing slowly, that will save you a lot of time. You won't have to try things over and over again. Okay, so let's go ahead and take a look at example 3, and it's the first one. It should be example 1. I don't know why it's example 3, but that's fine. All right, the first one I've got here. Determine whether each sequence is arithmetic or arithmetic, geometric or neither. If the sequence is arithmetic or geometric, circle D or R. So D is going to be the common difference, R is going to be the common ratio. D is equal to the difference, or common difference, and R is common ratio. Then find the common difference or ratio. We're going to find that already. All right, let's take a look at it. 0, 1, 3, 6, 10. Okay, whatever it's doing, it's not doing it very fast or very slow. Let's go ahead and do some subtracting backwards or subtracting left. And it doesn't matter if I start here or if I start here, if I start here, but I need to do it at least twice. So if I go backwards from here to here, I've got 10 minus 6, and that gives me a 4. Okay, if I go from here to here, and I'm only doing them so they're not next to each other because I don't have a lot of space with this big pen. So 3 minus 1 is equal to 2. All right, this is not arithmetic. So I do need to see if it's geometric because I've got a 2 here and a 4 here, and I'd have to have the same difference if it was arithmetic. So let's go ahead and do some division. And I've got a 10 divided by 6. And if I reduce that, I'm going to have 5/3. And here I've got a 6 divided by 3. And that's a 2. All right, so both tests failed. It failed being arithmetic. It failed being geometric. So in this case, this one is going to be neither. I don't have a common difference or ratio, and there's nothing to go there. All right, I'm going to switch to a different color just so I want to make sure everybody can see. We're going to test this one. Okay, again, I'm going to look to see if it's doing, whatever it's doing, is it doing it really fast or really slow? So 48, 24, 12, or 6, that's pretty fast. So I'm going to go ahead and try division first. I'm going to divide backwards first and see if it's geometric. So this divided by that. 6 divided by 12 is equal to 1/2. And if I do this one, 24 divided by 48 is also 1/2. Okay, so I've confirmed I don't have to do anything with arithmetic. I don't see anything that's being added or subtracted here that would work anyway. So I'm going to say that this is geometric. And it just did that again. I was hoping I'd gotten over that, but apparently not. So let's erase that. Okay. There we go. All right, I'll keep talking while I do this. It is geometric, and by dividing backwards, I found that I have a common ratio of 1/2. So I'm going to circle the R, and it's 1/2. Okay, let's go ahead and scroll again and get the rest of the examples up here. Okay, keep in mind the goal is to determine if I've got an arithmetic sequence, a geometric sequence, or neither one. Sometimes I can look at it and not even start to do any math, and hopefully you can do that too. Let's take a look at this one. 1, 1, 2, 3, 5, 8. All right. Is it increasing by the same amount every time? I can look at this. It didn't increase at all there. Here it increased by 1. It went from 1 to 2. 2 to 3 is increasing by 1, but 3 to 5 is increasing by 2. 5 to 8 increased by 3. So it's not arithmetic. And dividing backwards, 8 divided by 5, 5 divided by 3, that's going to give me 8/5 and 5/3. And no way is that working either. Okay, so this is not going to be geometric or arithmetic. This one is also going to be neither. And this is actually a really famous sequence. It's called the Fibonacci sequence. And what is happening here is, I don't need this. What's going on here, and I just want to erase this. This is a sequence that appears in nature, and it was discovered by an Italian hundreds of years ago. Most math is hundreds of years old. And we've got 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 would be 13, would be the next number. So this is definitely a sequence, but it is neither because it's not arithmetic or geometric. Okay, let's look at this one. -4, -1, 2, and 5. Okay, remember we're looking for ways to make this less work for ourselves. So whatever it's doing, it's not doing it really fast and it's not doing it really slow. So we're going to go ahead and subtract backwards to make sure it's not arithmetic before we worry about something else. And if you can see the pattern already, that's even better. Okay, so subtracting backwards here, I've got 5 minus 2, which is going to be equal to 3. And here I've got 2 minus -1, which is also going to be equal to 3. So since I got a 3 twice for the common difference, this is arithmetic. And I'm not quite sure why that has that line right there. Oh, I know why. We're writing down the common difference and what it is. Okay, up here, we are putting, this didn't have a common difference ratio. This had a common ratio of 1/2. Sorry about that. And this one was geometric. This one doesn't have one. This one, the common difference is 3. Sorry about that. All right, a couple more examples. This time we're going to use this idea of adding forward, subtracting backwards, multiplying forward, and dividing backwards, and we're going to find missing terms. Maybe. All right, determine whether each sequence is arithmetic or geometric. So they're going to all be one or the other. There's not going to be any neithers this time. And if it is, the common difference would be for an arithmetic sequence. A common ratio would be for a geometric sequence. And then we're going to find the missing terms. All right, -8, -5, -2, and 1. It's not doing it really fast, so we're going to go ahead and test to make sure that it's arithmetic. So I've got, going backwards, I've got 1 minus -2, and that gives me a 3. Okay, let's try it again up here because I've got enough space to see it. -5 minus -8. And that's also going to give me a 3. So we've just confirmed what we suspected, that it is arithmetic. It has a common difference, and what we found that to be was a positive 3. All right, so we subtracted backwards. We're going to add going forward. So to get this term is 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. So it's that easy. Okay, so we add forwards. I like this even better. And we subtract backwards. So let's go ahead and switch to a blue pen because I'm tired of red. All right, look at this. The signs are alternating, but look how fast this is doing this. If you ignore the signs and go with the absolute values, we've got from 8,505 to 2,835 to 945. It's dropping really fast, although the signs are alternating. So instead of wasting time subtracting backwards, I'm going to go ahead and divide backwards. So right here, backwards from here to here, I've got negative 945 divided by 2835. And that is going to be equal to negative 1/3. And I trust everybody's got your calculator and you can do that. Okay, now I don't have room to do, well, I've only got this one. So let's do this one. I've got 2835 divided by negative 8505. And that one's going to be equal to negative 1/3. There's not a little space here. All right, I have confirmed this geometric because I got the same answer twice by dividing backwards. That gives me a common ratio, and my common ratio is negative 1/3. All right, so now I've got to fill in all these missing terms. So I'm going to do, for this term here, I've got negative 945 times negative 1/3. Okay, so we are, at this point, we are multiplying going forward. And down here, we divided backwards. So this is going to give me a positive, because a negative times a negative is a positive 315. Okay, and if I keep doing that, this one would be 315 times negative 1/3, and that is going to give me a negative 105. And this last one is negative 105 times negative 1/3. It's going to give me a positive number. Let's see if I can write this one in because I want you to have enough notes. So a negative times a negative is going to give me a positive. These signs are alternating, and that's going to be a positive 35. So every time I multiply a negative times a negative, I get a positive, and the signs are going to alternate. And I'm going to make some room up here so I can have space for this one. So let's go ahead and erase some of this on the bottom. All right, negative 15, negative 18, negative 21. Whatever it's doing it really slowly. And in fact, if I look at this, I think what we're doing is we're either adding a negative 3, or we are subtracting 3, one or the other. So let's make up our minds what we've got. And I'm going to go ahead and, just to be sure, I'm going to go ahead and do this. Remember, we're going to subtract backwards. And when we get over here, we're going to add going forwards. So negative 21 minus negative 18 is going to give me that negative 3. So we are subtracting 3, or we are adding negative 3, however you want to say it. Here I've got negative 18 minus negative 15, and the same thing. It's going to be equal to negative 3. All right, so I've determined that it's arithmetic. Therefore I have a common difference, and that common difference is negative 3. Okay, so let's keep adding negative 3. So what's going to go right in here? We're adding forward. So negative 21 plus negative 3 is going to give me a negative 24. Negative 24 plus negative 3 is going to be a negative 27. Negative 27 plus negative 3 is going to be a negative 30. All right, now this one gets a little bit trickier just to start out with. Right on top of here, I've got negative 15 minus negative 3. So that's going to give me a negative 12. And this one's going to be negative 15 minus negative 3. And that's going to give me, excuse me, not negative 15, we're down to 12. Negative 12 minus a negative 3, that one's going to give me a negative 9. So you can see the pattern. It is decreasing by 3 each time, so it's a negative 3. So this one is going to be a negative 6. All right, couple more. 24 and 0.8. This does not look arithmetic to me. We had a pretty significant drop from 20 to 4 and from 4 to 0.8. So I'm going to try dividing backwards on this one first to see if I can save myself some time. So let's go ahead and switch colors just so it's a little bit easier to see. And I'm going to try dividing backwards this time and see if that'll save me some time. So from here to here, I've got 0.8 divided by 4. And that is going to give me 0.2. And from here to here, if you want to keep it as fractions, you can, but it's at this point, it might be easier to keep it. That's 2/10 or 1/5, which is, yeah, actually, I like 1/5 better, but we'll go with this. All right, 4 divided by 20, which again would be 2/10 or 1/5, but we'll go with the 0.2 since the person who put these PDF together went with the 0.2. All right, so we confirm by division, by dividing backwards, that's a really bad arrow, that this is geometric. That means that this is a common ratio, and it's 0.2 or 1/5. All right, now to fill it in this way, I'm going to keep dividing by 0.2. And I'm going to switch to green because it's getting really crowded. Okay, so I've got 0.8 times 0.2 is going to go in here because I am going to, wow, I just wrote that completely wrong and I'm going to confuse everybody. That should have gone the other way. We divide backwards. I really apologize. That should have been right here with a divide backwards, because that's what we did. And what we're going to do going forward is, of course, multiply. All right, back here. So multiplying going forward, 0.8 times 0.2 is going to give me a 0.16. Okay, 0.16 times 0.2 is going to give me a 0.32. And you probably could tell where this is going. If I keep multiplying this by 0.2, the next one's going to be 0.64. So the pattern is actually, and I'm leaving out the zeros. I needed a couple of zeros here too. Okay, sorry, it's Friday afternoon before Thanksgiving, and I'm full of mistakes today. Let's do this again. All right, this is 0.2 times 0.16. That's not 0.32, it's 0.032. You've got a calculator, you can confirm that. 0.032 times 0.2 is 0.0064. Now you can see the pattern, and that's much better. All right, 20 divided by 0.2 is what we're going to do backwards, and I'm going to switch back to the green so you can see what I'm doing. Okay, so right here, I'm going to divide backwards, and I'm dividing by 0.2, which is my common ratio. So this number is going to be 20, and I'm going to divide by 0.2. And that doesn't fit. Divided by 0.2, and that is going to give me a 100. Do you see how fast it's changing? And now I'm going to take, for this number, I'm going to have 100 divided by 0.2, and it's going to give me 500. And this is what I would expect a geometric sequence to behave like. So this one's going to be 500 divided by 0.2, and I think it's going to give me 2,500. True to geometric sequence, it went from 2,500 to 0.0064 in 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. And that's exactly how I'd expect it to behave. Let's get some of this out of the way, and I'll try and be clearer on the next one. All right, while I'm doing that, while I'm done, let's switch this back to a blue pen for a minute. Let's see if we can see what we want to do first. If we want to divide first, or if we want to subtract first. 1.5 and 2, 3.5 and 4. On a hunch, I think that we should subtract. I think that's going to be our best bet. So we're going to subtract backwards, and this time I'm going to write it correctly, which means that when I get up here to increase this way, I'm going to add going forward. All right, so I've got 2 minus 1.5, and that is going to give me 0.5. And I've got to double check it, so I've got 4 minus 3.5, and that's going to give me 0.5. So I have confirmed by doing this twice that this is arithmetic. And that gives me a common difference, and my common difference is 0.5 or 1/2. Okay, let's go ahead and fill in the terms in the middle. 1.5 to 2, and I'm going to do 2 plus 0.5. So this one is 2.5. This is easy. Plus 0.5 is 3. Look at the pattern. Whoa, great. Yes, I thought we had gotten past this, but apparently not. All right, one more time. Let's look at the pattern. So I went from 1.5 to 2. I went to 2.5. This one's going to be 3. 3.5 to 4. If I add 0.5, because I add going forward, this one's going to be 4.5. Add again going forward, plus 0.5 is going to be 5. Getting any easier at this point? Okay, I'm going to subtract going backwards. So 1.5 minus 0.5. Right here is going to give me a 1. And 1 minus 1.5 is going to give me a 0.5. See, it is getting easier. We've got one more example. Let's go ahead and clean this up and scroll down. All right, so to reinforce what we're doing, we are concerned at this point in Algebra 1 with just geometric and arithmetic sequences, or arithmetic sequences. It is just fine if you want to call them that. Geometric sequences increase or decrease by a common ratio. Arithmetic sequences increase or decrease by a common difference. And a common difference acts just like a slope. So let's put this back to the pen. Here's my last example. I've got a negative 27 to a 21, a negative 2187 to a 6561. Okay, so remember my time-saving tip. The signs could alternate, and in fact, in a geometric, they can't do that in an arithmetic sequence. So the fact that these signs are alternating pretty much is a dead giveaway that this is geometric. And if I look at what's going on here, if I take the absolute value of this, 27 to 81, and the absolute value of this, 2187 to 6561, whatever it's doing it really fast. It's not doing it slowly. So I've got 2 points here that make me think this is geometric. So to save myself some time, I'm going to go ahead and divide backwards. So we're dividing backwards. Now that I've got my notation all figured out, I've got 6,561 divided by negative 2187. And what that is going to give me is a negative 3. I have to do it twice. I got to make sure that that's what I actually have. So let's do it here. 81 divided by negative 27, and that's going to give me a negative 3. All right, so I've confirmed because I've done it twice, and I looked at the pattern, and I'm pretty sure what's going on here, that this is geometric. That means that it's a common ratio, and that common ratio is negative 3. Okay, so to go forward, I divided going backwards. I am going to multiply going forward. My cute asterisk. All right, so 6561 times negative 3 is going to go in this spot. 6561 times negative 3. It's going to be a really big number. I don't even know if it's going to fit. 19,683, and it's negative. Negative times a positive. So negative 19,683. And we're going to multiply that, negative 19,683 times negative 3 to fill in this one. So this is going to be positive this time, negative times a negative. And this is a huge number. This number is 590,000. Oh, excuse me, 59,049. I went too far. Okay, so true to form, it's increasing really, really fastly, other than the signs are alternating. Okay, so from get to here, I'm going to do 81 times negative 3. And that's going to give me negative 243. And this one is going to be negative 243 times negative 3. This one's going to be positive this time, and it is 729. So we multiplied going forward. Now we've got to go backwards. We don't have any choice, so we're going to divide. Negative 27 divided by negative 3 is going to give me a positive 9. And this one is 9 divided by negative 3. It's going to give me a negative 3. And that would be very much like a geometric sequence. Went from negative 3 to 59,049. It did it in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps. All right, so you've got some practice. We're going to get more into arithmetic and geometric sequences in the next few lessons. Then we've got some word problems. And then that wraps up Chapter 6. And we are very nearly approaching Christmas. So have a good day. Bye.